Now remember, when we look at binary molecular compounds, the fact that it's binary means that we have how many elements?
2.
2. If it's molecular, that means we are bonding a nonmetal to a nonmetal. And so basically we're going to be working with elements that are over in this portion of the periodic table right here. Binary molecular compounds. So for these, we'd have something like ClF3 as an example. Or we could have something like P2Cl4. If we want to write a name for each of these, here's the convention we use. Now the convention that we're looking at here will look very familiar to us because it starts off identical to how we name binary ionic compounds. We say that the first element retains its name and that the second element retains its root name, onto which we add a suffix of IDE. And so again, this is identical to what we did when we looked at the binary ionic. But we add on a third one. And the third one here says that Greek prefixes are added to indicate the number of atoms of each element shown in the formula. So again, Greek prefixes are added to indicate the number of atoms of each element shown in the formula. Yes?
Why is it necessary to do that? I mean, not like carbon dioxide, for example, but like someone thought, why don't we say like disulfur or something?
So when we're dealing with molecular compounds. So when we deal with the ionic compounds, which are metal and nonmetal, then we don't use those prefixes. It's only when we're dealing with these molecular compounds. Now the prefixes that we're going to use, these are shown, if you need them again, these are shown in your text on page 145. And those prefixes are, and again these are to memorize, but you know most of these already. They are the prefixes mono, di, tri, tetra, penta, and then we have hexa, hepta, octa, nona, and deca. So of course, if you're riding a three-wheeled thing as a kid, we call it a tricycle. The shape of a stop sign is an octagon. It's 8-sided. And if you're working with nuts and bolts, most of your nuts are called X nuts because they have 6 sides. And if you go to Washington, D.C., the 5-sided building is called a pentagon. Okay? So, what that means then, in terms of these formulas, and of course, if you've been around 10 years, you've been around for a decade. So you know these. So if we want to name this one, this first one is going to be called chlorine. Oh, and by the way, the prefix mono, and this might be what you were asking about. Prefix mono is usually left off, except in carbon monoxide. So the prefix mono is left off of this one, but this would be chlorine trifluoride. Good. Chlorine trifluoride. And in the next one, this would be diphosphorus. The prefix it stands for is tetrachloride. Try diphosphorus tetrachloride. If we had this stuff, SF6, this would be sulfur hexafluoride. Going the reverse direction is easy. Let's say we had diarsenic pentaiodide. Diarsenic pentaiodide. Because these are all nonmetals bonded to nonmetals, there's no charges involved. We simply look at the prefixes, and the prefixes tell us how many atoms there are of each element. So arsenic is As, and how many would we have? 2. Then pentaiodide would mean I5. If we had this next one, tetraphosphorus decoxide. And by the way, I am spelling this correctly. Don't ask me why we make up these rules, I don't. But whenever a Greek prefix is adjacent to oxide, the letter A is left off. So if it's deca, we don't call it decaoxide, we call it decoxide. So the letter A is left off when the name is adjacent or immediately preceding oxide. So if you want to write the formula for this, this would be P4O10. P4O10. And likewise, if we had a name for this one, that is N2O4, this one would be called dinitrogen tetroxide. Again, without the letter A in there, whenever these Greek prefixes are adjacent or come immediately before oxygen, the letter A is left off. We don't do that with iodine. I'm not an English major, so I don't know that reason, but that's just the way it is. There's probably some weird historical rule that dictates what it is. Now, what happens here, though, is something like this. We've gone through all of this, and then when we go to something like AlCl3, people forget the rules we've already learned. And you might remember the way we started all of this nomenclature is we asked ourselves to classify them. So before we assign a name, we need to classify. And so if we classify this one, is this an ionic compound or is this molecular? It's ionic. And why is it ionic? Metal and a nonmetal. And whenever you have a metal and a nonmetal, then we don't use the prefixes. And so the name of this simply would be aluminum chloride. The only time we use the prefixes is when we have a binary molecular compound. And the reason why we do it there is because there's often multiple ways that those elements can combine together, nonmetal to nonmetal. So the prefixes, I say people get prefix happy. They want to use them all the time once we learn them. But we only use the prefixes whenever we're dealing with molecular compounds.